In this video we're going to look at evaluating the database structure and validation for legend events. You'll be told exactly what to evaluate. So in this case you should consider how well your database structure has minimised data duplication and how well your database structure meets these requirements. A record will not save if a customer selected is invalid. A record will not be saved if the cost per guest is below the accepted range. A record will not save if the cost per guest is above the accepted range. And a record will not be saved if the dietary requirements is invalid. Now you'll notice that the evaluation is actually split into two main parts. We've got this first part, how well your database structure has minimised data duplication. And then we've got this second part, how well the database structure meets these requirements. The way I'm going to approach this evaluation is I'm going to deal with this first part and then I'll deal with the second part. And each part we can divide into subparts. So this is the first part, structure minimises data duplication. So what we need to think about is, first of all, what is data duplication and give an example. We need to sort of say what's the purpose of normalisation and a relational database. And then what have we ended up with following normalising the sample data? And for example, you need to name the entities, the primary and foreign keys and the relationships. Use examples from your sample data to support your explanations and link it to your database structure. Let's have a look at some sample paragraphs. So here's the first part. Data duplication occurs in a database where data is stored a number of times in one table. An example of this will be where Green has booked 3 events. And if this person's details and events were in one table, the details about Green, i.e. surname and phone number, for example, would be duplicated. So the issue with data duplication is that it increases storage requirements and it's difficult to keep the data error-free, e.g. if Green's phone number needed to be changed, it would have to be changed in 3 records. I've then got a paragraph about the purpose of normalising the data. So the purpose of normalisation is to organise the data and minimise data duplication. Each attribute is stored once only, with the exception of foreign keys. These are copies of primary keys and are used to create relationships between tables. Using relational databases and normalising data eliminates data redundancy, and this will ensure that the data is error-free and storage is used efficiently. Then got a paragraph about what we've ended up with once we've normalised the data. I've normalised the sample data and identified 4 entities: customer, event, guest and event guest. Each entity has a primary key. For example, customer has a primary key, customer ID. On the many side of the relationships, there's a foreign key that links 2 tables together. For example, in event, there's a foreign key of customer ID. Customer ID is the primary key in the customer entity. There is a one-to-many relationship between customer and event, and a customer can book a number of events and an event only has 1 customer. The second part of the evaluation covers evaluating the structure to see if it meets the requirements. And again, I've split this up into 3 main areas. The first one is that the cost per guest is between £10 and £50. We need to evaluate if the dietary requirements are non-vegan, veg or gluten. And we need to evaluate that a customer selected is valid for an event. Again, only write about what you've been asked to write about in your activity. Use examples from sample data to support your explanations and link to your database structure and validation used. This is the first paragraph in the second part. One requirement for legend events was to ensure data integrity and make sure the data was accepted. Cost per guest is between £10 and £50. I've used the currency data type for this field, which is an initial validation, as only numbers, digits can be entered. I've applied range validation to the cost per guest field, limiting the user to entry to between £10 and £50. An error message is displayed if the user enters less than 10 or greater than 50. The event record will not save until a number between 10 and 50 is entered. This is the second paragraph evaluating if the structure meets the requirements. Another example of ensuring data integrity is where I have provided a table lookup value list for the dietary requirement. The user has to select a requirement from the list: non, vegan, veg or gluten. If the user tries to enter something not on the list, an error message is displayed. The user is not able to add to the list, as I've used limit to list in the field's property. And this is the final paragraph regarding the evaluating if the structure meets the requirements. Each event is booked by a customer, but a customer can book a number of events. Customer ID is a foreign key in event, and I've used a combo box, table lookup foreign key for this field, and enforced referential integrity. This means that the user can only select numbers in the combo box or key in numbers that exist in the customer table. Customers that do not exist cannot be stored for an event. If more than one customer could book the same event, then this will be a many-to-many relationship, and a new entity between customer and event will be needed, as many-to-many relationships cannot be implemented in a relational database. This video completes part A of the syllabus or the exam. In the next videos, I'll be looking at part B, which is creating the forms, the interface for the database.